Section 6.3, we're going to do truth tables for propositions. And in a minute here, you'll understand the significance of truth tables. You remember when we were working on Section 6.2 on truth functions? I had a proposition, and I assigned A, B, or C. Those were letters standing for simple components or a simple statement, either a true or a false. And if it was D, E, or F, we assigned that. D, E, and F was a false, and A, B, and C we assigned as true, right? And we took this proposition with that particular line, knowing the truth value of the simple components. And remember, the value of the compound proposition is a function of those simple components, what their particular truth value is. Well, now we're going to go over truth tables, and truth tables allow you to see every single possible line for that proposition all at once, okay? And so that's going to be the power of a truth table. You're able to see everything at once, not just do it line by line, individually and separately. You can write out all the different combinations. The statisticians have helped us here, and then do the truth table for the whole proposition. And you need to know how to do truth tables because we're going to need them later on for several things, okay? So let's start with the handout here. As I said previously, I showed you how we can determine the truth value of a compound proposition given a certain designated value for the simple components of that compound proposition. And a truth table, basically, it's going to exhaust the entire range of possibilities, and that's why they're useful things. So what I'm going to do is to show you how to construct a truth table, okay? And I'm going to go through the steps, and then I will show you with a couple examples how to actually do that, okay? So let's say you are given a proposition. You first of all, for a truth table, have to determine the number of lines, okay? So the number of lines, there's a formula. The number of lines, that's what number L is here, is equal to 2 to the n. So L stands for the number of lines, and this little n stands for the number of simple propositions, okay? Now I want to be careful. When I mean simple propositions, here's an apple pie English way of understanding that. How many different alphabet letters do you see in the proposition, okay? So if you see a not A in the proposition and then you see an A, don't count that as two different propositions. All I see is an A. The only alphabet letter is an A. The not A doesn't change the fact that we're dealing with one proposition, and then over here it's just negated, okay? So when you're determining n, don't have something where you count too many, okay? So if you have not A and A, that's still just one. If you have something that has both B and D, if both B and D, then not B. The number of simple propositions here is still just 2. I see a B and I see a D. Those are the only two distinct alphabet letters, okay? So that's what n is. If you want to determine the number of lines for your truth table, that's the first step. You have this proposition, you want to know how many lines. It's 2 to the n, and n is how many simple propositions are in the compound proposition, and the way to find that number is how many distinct alphabet letters do you see. Just because something has a tilde in front of it doesn't make it another proposition, okay? Then what you do is divide the number of lines in half with this number. So, and then you go to the first simple component or letter and write true on the same number of lines. You're going to finish out the column with an equal number of false. And don't worry, as I go through these, when I do these examples, they're really going to help. So let's say the number of lines in a proposition are 4. So, you know, we can actually do this one right here. Let me erase this stuff here. Let's say this is our proposition, okay? The number of lines is 2 to the n. So what is n? I see two distinct alphabet letters, so it would be 2 to 2. And 2 to the second power is 4. And we probably should take care of that now. Maybe some of you, it's been a long time since you've had math. Here's the only math you need to know for truth tables. 2 to the 2 means you multiply 2 by itself twice. It means 2 times 2, and that's equal to 4, right? If you have 3 simple components, 3 different alphabet letters, that's 2 to the 3, and that means you multiply 2 by itself 3 times. So 2 times 2 times 2, and you can see that that is equal to 8. All right? 2 to the 4th power is you multiply 2 4 times by itself. Okay, 2 times 2 times 2 and times one more 2 equals, what does that equal? 16. Okay? I'm not going to assign truth tables with any more than 8 lines. I don't see the point having you do a 16-line truth table. If you make a mistake, it's probably not because you don't understand truth tables, it's because you made a bookkeeping error. So they're going to be 8 lines at most. But if we're taking this one here, the number of lines would be 4, right? 2 to the 2, 2 different alphabet letters. 2 to the 2 is 4 lines, okay? So we know it's a 4-line truth table, and then step 2 is divide the number of lines in half. So you divide 4 by 2, and this equals 2. And the reason you divide that is this 2, you have the number of lines, go ahead and divide it by 2, which is 2. The 2 here means you go to the very far left simple component, which here would be a B, right? And it says you start off with true, and you write true, and don't switch to false until after the second line. You know, let's go over here, and I can show you how this works. Okay, let's go farther down. Okay, actually, let me go back and just remember what that thing was here. Okay, let's go here. Okay, we had if B and D, then not B. Okay, let's go back here, and I will write that down. Okay, so I'll show this step to you here. So we have if both B and D, then not B. Okay? So the number of lines is equal to 2 to the n, right? There are 2 different alphabet letters there, so 2 to the 2 is equal to 4. And then, step 2, you divide the number of lines by 2, and that is equal to 2, right? Okay, what this 2 means is you go to the first simple component on the far left, and the 2 just means you switch to the other truth value after 2 lines. There's only 2 truth values for a proposition, true, false. So you start with true, and it says, you know it's 4 lines, okay? It's a 4-line truth table, so I'll just draw these in here. Okay. All right, let's come down a little bit here. Okay, so number of lines is 4. 1, 2, 3, 4. You divide it by 2. All this 2 tells you is you go to the far left alphabet letter, and this is the first simple proposition listed in this compound proposition. And the compound proposition, this is a conditional, right? That's the main operator. And this says don't switch to false until after the second line. So you go true, true. That's 2 lines, right? 2. 2 says switch to false after the second line, false, false, okay? And then what you do is if you see B again, go over to the B and you can just duplicate this line, okay? So true, true, false, false, okay? Now, with this 2, you divide this again by 2, and that equals 1. And you guessed it, this 1 means go to the next distinct alphabet letter, the next simple proposition in line that's different, that's distinct from the first one, and you switch from true to false after one line, so every other line. So true, one line, switch to false. Then switch back to true, then switch back to false. Okay? And then the truth table is done. And then let's just go through these rules now, make sure we haven't forgotten anything. Okay, so first of all, when you're given a proposition, determine the number of lines needed for the compound proposition that you were looking at. We've done that. It's 4. You remember we were looking at this one. It's 4. Divide the number of lines in half with this number. So 4 divided by 2. Go to the first simple component or letter and write true on the same number of lines. Hopefully this is starting to make sense. Finish out the column with an equal number of false. Then divide the above number again by 2 and keep this number in mind as you fill in the truth values under the second different simple component or letter. If the first column has 4 trues and then 4 falses, this next column would have 2 trues, then 2 falses, then 2 trues, then 2 falses. Okay, so if you had that means you have an 8-liner. If you had an 8-line truth table, divide that by 2 and it's 4. That means after the 4th line, switch to false. So true, 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 false, 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 false. Then you divide 4 by 2 and that's 2. You go to the second simple proposition and you switch after every 2 lines. So true, true, false, false, true, true, false, false, right? And then you'd divide that 2 by 2 again. 2 divided by 2 is 1. And that means for the next proposition, which will always be the last one when you're switching after every 1 line, it means you've kind of crescendoed down. I don't know if you can see that. You start bigger lines and you move and you crescendo down. Your last proposition should always be true, false, depending on how many lines it is. Okay? So let's just, I think there's one other thing I want to say here. Okay. And if you're at your last simple proposition, it should be true, false, etc. And I already mentioned this previously. If you see the same letter, if you see B and then B appearing elsewhere, whatever you wrote down for B the first time, you can duplicate the line. Okay? Then what you'll do, once you have all these true, falses listed in there, then you will use the chart, the truth value for the operators. You remember this? Just kind of go close there. There you go. You'll pick that up and you'll use that to fill things in, okay? And so you want to have that handy as you're following this. Now I'm going to do a couple of examples and this is all going to make sense, but and then we're going to do this in some other videos, so I'm going to keep repeating doing these truth tables with you because we're going to need them for other applications. But let's go to 2 examples and I think they're going to help. Okay? So let's go to our graph paper. And if you do have graph paper, this certainly can help. Oh, we'll just stay up here. Okay. So here we have a compound proposition. It is a conditional, so we know what the main operator is. First of all, we want to determine the number of lines, right? The number of lines is equal to the n. How many simple propositions do you see there, or how many distinct alphabet letters? Well, I see an A and I see a B. So this would be 2 to the 2. Don't you dare put 2 to the 3. Remember, not B is not a third one. I just see an A and a B. And that tilde doesn't change the fact that it's just a B. So it's a 4-liner, right? 4 lines. And you divide that by 2, which is equal to 2. And what this 2 tells you is, go to the first simple proposition and write true down on the first two lines and then switch to false. So that's what we're going to do. So true, true. This to means switch after two lines. False, false. Okay, and then if we were switching after two lines, you're supposed to divide this 2 by 2 again, and 2 divided by 2 is equal to 1. So 1 means go to the next simple proposition, and the 1 will tell you this should be the last distinct one, okay? And you were to switch from true to false after every other line. So this would be true, false, switch after one line, switch again true, switch again false, and we can duplicate this. See the B here? Remember I said duplicate? So just come over here and duplicate that B column. True, false, true, false. Okay, now this is a conditional, so remember this B is the Q. If you had a if P then Q, this is reviewing what we did last video on truth functions. So if P then Q, the Q happens to be this proposition. Maybe it's boys mature later in life than girls. It could be that. But I want you to see for this conditional, the B is the Q, okay? And I want you to see that this disjunction, see this whole disjunction here? This whole thing is the P. So you have if P then Q. The Q is the B, whatever B stands for. The P happens to be this disjunction for the conditional, okay? All right. Oops, let's go. Oh, wait a minute. Okay, so let's remove that blue here. We can do that. Okay, just so you all understand it now, let's focus on this. We don't have to do any work here because this is all done, right? We don't have to work on the A because that's all done, but look at this, the tilde B, we need to work on this, okay? Because inside the parentheses, this is a disjunction. In a sense, the wedge is the main operator just inside the parentheses, right? Right here, we have to, if it's a tilde B, that means if B is true, then tilde B is false. This would be true. If B is false, not B is true. If B is true, not B is false. Okay, so it's basically false, true is the negation of true, false. And you can have different colored pens. You know, you can cross this out like that so you don't get confused. Whatever you want to do now, we have this column here and this column here, and this is a disjunction. So you want to pull out this again, and I'm not going to go back and forth to refer it. You should have this in front of you. So for the disjunction, remember, if you have at least one true, the disjunction is true. So true, false, this is true. Remember, this is the P, and this right here is the Q for the disjunction. So true, false, that's true. True, true is true. False, false, if you look at your tables for the disjunction, that's the only time a disjunction is false. And false, true, that's true. Okay, so we have this row here, column there, and that column. Now we go to the horseshoe table. So go back to this here and find the conditional table, and we do this row by row. So here we have true, true for a horseshoe is true. Okay? True, false for a conditional is false, right? False, true is true, and true, false is false. So if we come down here, we're finished with the truth table. This is the final column. Okay? It's true, false, true, false. And you got to remember, this whole thing here, what we did on this column, this is the P. And over here, this is the Q. And you remember when I said a truth table exhausts all possibilities? Here's what the logic people did. They went to some statisticians and said, is there a way to draw out, to write out all the different combinations for a proposition all at once? And when I was doing the L is 2 to the n, the number of lines, divide by 2, before I started using this, you see, that is exactly what the statisticians enabled us to do. They enabled us to exhaust all the possibilities and write it all down. And then we can go line by line. And you remember when we were doing the previous video, we were just doing one line, right? And I told you, well, A is true, B is true, and B is true, right? And we did that line. Do you see here? We did all possible lines all at once. Okay, let's go to another one here. All right. Now, first let's get the number of lines. That's the first thing we got to do for this truth. So it's a compound proposition. It also is a conditional. L is equal to 2 to the n, the number of lines. How many distinct alphabet letters do you see in this one? I see 3. A C, a D, and an E. So it's 2 to the 3rd power, and that is 8 lines. So we know it's going to be 8 lines. So you take the 8 and divide by 2, and that equals 4. And you guys got to realize, don't be intimidated by this part. This stuff is mind candy. You can do this in your sleep. Okay? There's nothing hard about this. You just got to practice. So remember, the 4 means go to the first distinct proposition listed. It'll be on the far left. And you switch to false after 4 lines. So I already know with an 8-liner, you're going to do this. True, 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 true. 4 lines, switch. False, 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 false. Okay, and let's do this to demarcate things here. Okay, then we divide that 4. Divide the 4 by 2, and that equals 2. This means go to the next distinct proposition and you switch to false after every 2 lines. Okay, so we got true, true, switch, false, false. That's 2 lines, switch again, true, true. Oh, 2 lines, switch again, false, false. Then you divide 2 by 2, that equals 1. This says you should switch every other line between true and false, and this should always be the last remaining distinct proposition. So we come to the last one, true, false, true, false, true, false, true, false. Okay. This truth table is all lined up, and you see with every line, true, 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 or true, true, false, or true, false, true, true, or true, false, false. If you tried to think of any combination and said, oh, I bet you haven't thought of that one, well, it's already there. The statisticians just help us just throw down. This is all down there. Okay, and then we're going to use the definition of the operators again. Don't worry, I won't be doing this in every video. You use this chart, right? And you come over here. Now, I have the chart memorized, and you'll have it memorized pretty quick, too. Okay. And you fill this in. Now, the work is all done here. The work is all done here. We have to work on this one. So if D is true, true, false, false, true, true, false, false, not D is going to be, let's switch colors here, is going to be false, false, true, true, false, false, true, true. Okay? And you can maybe put a line through that just to don't get confused. Now, we want to, this is a conjunction, so we're going to use this column and this one under the tilde. We ignore this one, okay? So for a conjunction on your definition of the operators, true, false, you remember a conjunction's only true if both are true. So if you don't see 2 trues, it's false. So actually, let's go ahead and use different colors. Let's use green here, okay? So false, false, true, because see, true, 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 false, 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 false. Okay? And then we're going to use this column and this one to find out what the main column is for this. Okay? Alright, so we're using the horseshoe. So on your definition of the operators, you want to go to the horseshoe table, right? So false true for a horseshoe is true. False false is true. True true is true. True false is false, right? False true is true. False false is true. And see, I can tell with these falses, it's always going to be true for the conditional. The only one where it's false is true false. Okay? And there you are done with your truth table for that one there. And that's how these are done. Now, let's just make sure you understand again with this. You realize this here let's go black now. This E is the Q, right? This entire conjunction, that is the P for this, okay? I want you to see these things. So this is if P then Q, the P happens to be a conjunction. The Q happens to be whatever E stands for. Remember, Q can stand for any proposition, a simple one or a compound one. It stands for a simple one. P can stand for any proposition, a simple or a compound. Here, P is actually a compound proposition, a conjunction. And within this conjunction, if we were just looking at the conjunction, I hope you can see that C would be the P and not D would be the Q if we were just looking inside there, okay? It just depends on what scale you're looking at, all right? But you want to keep things in perspective. What is the main operator? And then what are the main operators within a little parentheses, even though it isn't the main operator of the compound proposition, okay? All right, I'm going to stop here. This is how you do truth tables for propositions, and we'll keep revisiting this. We're going to still stay in section 6.3, and I'm going to show you how to compare two statements using truth tables and the terms that you give two statements based on how they turn out with the truth tables, and how to classify single statements. Actually, we'll classify statements first and then we'll compare them.